Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about algebra, functions and integration. Now the question I've chosen to go through here is 2018 paper 1 question 6 part A. In this question we're given a graph that has the graph of h of x equals x and k of x equals x cubed. We're asked to find the points of intersection of these two functions. X is just a straight line, whereas x cubed is a cubic. Okay? To find the point of intersection, you just let h of x equal to k of x. In other words, you just let x equal to x cubed. Now, when I have this stage, I just bring my x to the other side, and I get x cubed minus x is equal to 0. All you can do at this stage is factorize out your x. If you factorize out x, you're left with x squared minus 1. You should recognize then that x squared minus 1 is the difference of two squares. So this just becomes x minus 1 times x plus 1. So they're your three factors. And if I'm trying to find the points where they intersect, I need to convert my factors into roots. So I can say x equals 0, x minus 1 equals 0, which means x is equal to 1. And I can say that x plus 1 equals 0, which means x is equal to minus 1. Now it asks me to find the points of intersection, so my answers need to be points. It's very easy if you know your x values in order to find your y values. Because if you just view this one, h of x equals x, you could just view that as y is equal to x. Whatever your x value is, then your y value is the same. So that means if x is 0, then y is 0. If x is 1, then y is 1. If x is minus 1, then y is minus 1. So your final answer there is just those three coordinates. Okay, in the second part of this question, we're asked to find the area enclosed between the graphs of the two functions. Now you have to be careful here. Notice that I've only drawn half of the graph. What I'm actually going to do is I'm going to find the area between the graphs of the two functions just when it's above the x-axis, because the section here and the section below the x-axis will actually cancel each other out. If you try and do this for the whole thing at once, they'll actually cancel each other out and you'll get 0. So you need to find the area enclosed just in the upper section and then multiply it by 2. You could get the area enclosed by the lower section and multiply it by 2 as well. You get the same answer. But the problem is, if you get the area of the whole thing at once, the area at the top and the area at the bottom will cancel each other out and your answer will be 0. So I'm only concerned with half of my diagram here. H of x is the straight line and k of x is the curve. I know that they intersect at 0, 0 and they intersect at 1, 1. And I need to find the area between the line and the curve. Now there's a couple of different ways of doing this. I'm going to do this purely just by integration. First of all, you could integrate to find, so do you see the first bit here? I have the integral of x dx. In other words, the integral of the line. If I get the integral of the line from 0 to 1, that would give me this whole region. That would give me the area between the line and the x-axis. That would give me this whole region. It's actually just a right angle triangle, so you could have gotten your area by half the base by the perpendicular height. But if we do it by integration, the integral from 1 to 0 of the line h of x would give me all the area, everything below the line from x is 0 to x is 1, which is this whole triangular section. Clearly I don't want the whole triangular section, I just want the area in between the two curves. So the second thing you're going to do is you're going to get the integral of the curve from 0 to 1. The integral of the curve from 0 to 1 would just be this section here. That's the integral of the curve from 0 to 1 is just what is below the curve, between the curve and the x-axis from 0 to 1. In other words, this shaded region here. So if I get the area of the full triangle, and then I get the area of this bit in the middle, this bit outside, remember the question is to get the area between the two curves. So the first thing I work out, the triangle minus the bit that I've shaded, will leave me with the bit in the middle. So that's how I'm going to work this one out. I'm going to get the integral of the line from 0 to 1, which is this whole rectangular section, and then I'm going to subtract the integral of the curve from 0 to 1, which is this obscure shape on the outside. If I get the triangle minus the obscure bit, I'm left with just what I've shaded in there now, the difference between, or the area between the curve and the line. Remember, I'm only doing it from 0 to 1, and then I'm going to multiply it by 2 to get the region that's below the x-axis out here. Since the limits of my integrals are the same, I can just put them as 1. I can write that as the integral from 0 to 1 of x minus x cubed dx. The integral of x becomes x squared over 2, and the integral of minus x cubed becomes minus x to the power 4 over 4. Once you ditch your integral signs and you introduce square brackets. And outside the square brackets I have my limits from 0 to 1. Now to apply my limits, I just sub in my upper limit into that. I get 1 squared over 2 minus 1 to the power 4 over 4. And I apply my lower limit, which is 0 squared over 2 minus 0 to the power 4 over 4. Now obviously this whole section just becomes a 0, but this section, if you plug it into your calculator, works out as a quarter. So you know that the area between the line and the curve from 0, 0 to 1, 1 is 1/4. Obviously, if you look at your diagram, it's perfectly symmetrical, so the area here is equal to the area below it, is equal to the area below the x-axis, the bit of our graph that we're ignoring. So you need to multiply this by 2. So the final answer is actually twice that value. Your final answer, 1/4 multiplied by 2, is a half. So the area between the curve and the line is a half, and you can introduce units to be squared. Since it's area, it's probably safe to just put in your units. So it's a half unit squared. In the final part of this question, we're asked to draw the graph of the inverse function of k of x. So k of x is equal to x cubed. If I want to get the inverse function of k of x, I always just view this, the x that's in the brackets here, you just view it as an x. You get rid of the k and the brackets. And what you want to do now is you want to take the x on the right hand side and you want to isolate it. So in other words, I want to get rid of that cubed. In order to get rid of that cubed, you would get the cubic root of both sides. The cubic root of the right hand side is just x, and the cubic root of the left hand side just becomes the cubic root of x. So now you've isolated what was the x over here. Once you've isolated it, you can call that's k inverse of x. That is the inverse function of x. You now have k inverse of x is the cubic root of x. And that's your function. So they asked you to graph it, you can just graph that. So you'll notice here, that's what I've done over here. I've written out all my coordinates. If you sub in x as minus 1 the whole way up to 1, I'm going up in 0.2s. You go up, if you sub each of those into your calculator, they're your corresponding y values, and you can just draw your graph. So basically all that is you're subbing into a function. For me, I think that's the best way you should have done it, is because if I'm correct in that, you've loads of actual values and I can tick them, I know that they're the right coordinates. They also refer to it that you could use symmetry, because I want you to recognize that when you draw all of these points, if this is your graph originally, the other graph, the k inverse of x, is just symmetrical. It's just, it looks similar to it, and basically they just form that kind of a shape. So for me, you should have got your k inverse of x and plotted out all your coordinates, and your final graph should look something like that. So I hope this video makes sense. If there's anything there you're unsure of, then just let me know in class and I'll try and clarify it for you.